Okay, last four sections have been about solving quadratic equations by using the distributive property, by factoring two different ways, by using difference of squares, by completing the square. Now we're going to put that all together and show you again those two no-fail ways in order to solve an equation. One of them is called the quadratic formula. And before we get to that formula, we have to go ahead and look at this number one. We use the following formula to evaluate quadratic equations, and we've looked at this. This is that ax squared plus bx plus c, where we know a, b, and c. A and b are coefficients, and c is a constant, so they all have numerical values. So we're supposed to state the values of a, b, and c for this following equation. Okay, well, a, b, and c. We know that they have values. A is always that leading coefficient. Right here, there's nothing out there, but I know that there's a 1. B is the coefficient attached to the exponent of 1x, so that's 2, and our constant is -3. Okay, so get used to understanding those values because here we go. So far, we have looked at many different ways to solve quadratic equations. We will finish this chapter by looking at two fail-safe ways to effectively solve quadratic equations. The first is called the quadratic formula. Now, some very intelligent person many years ago found out that in order to solve for x in a quadratic formula, you can plug all of the different values into this formula and you will find an answer. Okay, so you can pull it apart to understand all of the pieces, but for right now, we are just going to say thank you, very smart person, for putting together this formula. We're not going to pull it apart. But what this says is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there's where our a, b's, and c's come into play. Notice there's only really two numbers in there. The rest are the variables that come from our formula. So as soon as I know that I'm using the quadratic equation, I know that I'm going to look at the values of my a, b, and c. And I'm going to go ahead and plug it into this formula. So I know that I'm going to have a negative b. Negative means opposite. The opposite of b, plus or minus, and I'm going to explain that plus or minus in just a second. B squared, so 2 squared, and I'm subtracting 4 times a, which is 1, times c, which is -3, and I'm going to divide all of that by 2 times a. That's a lot of stuff going on, but let's go ahead and simplify. Okay, first step, plug in. Second step, simplify. So we still have -2 plus or minus 2 squared is 4. A -4 times a 1 times a -12 is a positive, I'm sorry, times a -3 is a positive 12, all over 2 times 1, which is 2. Okay, I'm going to keep going with this. I have -2 plus or minus square root of 16 over 2. Now, this is where that plus or minus comes into play. Remember how we said that 95% of the time we're going to have two solutions to a quadratic equation? This is where that happens. We are going to set up two equations. -2 plus, well, square root of 16 we know is 4 divided by 2, and -2 minus 4 divided by 2. Okay, -2 plus 4 equals 2 over 2, so we know x equals 1. This one, if we add the opposite, we get -6 over 2, so we know x equals -3. Okay, quadratic formula, fail-safe way. I hope that you looked at one and said, well, we could actually factor that because this is saying what times what gives me -3, added together a +2. Well, that is a +3 and a -1. And if I set that equal to 0, I can see that x equals -3 and x equals 1. Did I get the same answer? Up here I factored. Up here or down here I used quadratic equation. Notice this is a fail-safe way. We could do an easily factorable one. We could do one that took completing the square to solve. Any kind of quadratic formula we will get an answer out of. Okay, now I'm going to go back into the calculator to show you how to use the calculator to graph this. This is that other fail-safe way. Either use the quadratic formula if you're good with numbers, or if you're good with calculators, go for this. So I'm going to rewrite this so I can move this down. All right, go ahead and get out your graphing calculator. Okay, I went ahead and put out the directions on how to graph this. First off, we're going to plug that equation into y1, and then we're going to hit second trace and ask it to find the zeros, because again, what we're looking for is the intercept when x squared plus 2x minus 3 equals 0. They're going to ask about that left bound and right bound, and basically what we're doing is telling the calculator that we're looking for the solution between this this area and this area. And that'll make more sense once we get into the actual problem. So let's go ahead and do this. We're going to hit that y equals. We're going to put in, remember, here's our x. There's a squared button right there, plus 2x, and then minus 3. We're going to graph that. I forgot to say, and graph. Okay, problems like this, we can actually see the solution right away. I see x equals 1, and I see x equals negative 3. I'm going to show you how to do this left and right bound. If we hit second trace and 0, notice where it is. This is left bound. Again, if I want this one right here, I'm going to have to hit this arrow until I'm to the left of that solution. So what that's doing is it's kind of breaking. Okay, so if I hit to the right of it, okay, what I just did was I told the calculator that my solution is somewhere between these two values. We don't guess, but there it is at negative 3. The reason I have to do that is how many solutions are on this? 2. So it needs to know that I was looking for that solution. So now if I hit second trace and ask for a 0, again, now I want to look for this solution. So my left bound is going to be below the x-axis, so I'm to the left of my solution. Now I'm to the right of my solution. No, thank you on guessing. So again, now it knows that it's going to zero on that solution right there. Answer 1. Okay, so however good you are at calculators, sometimes that's the best way. And I'm just going to sketch this. Okay, and again, I'm going to show you how that works. So left bound is here somewhere, right bound is here somewhere. So this is left bound and this is right bound. Here it's opposite, but here's my left bound because it's to the left of that solution, and here's to the right. And the nice thing is you don't have to be completely exact. That left bound could be way up here, okay, or pretty close to it, however you want to do that. All right, but a couple quick little tricks on how to quickly get an answer. Okay, so we're going to use quadratic formula, and we're going to use graphing on the very last way on how to solve quadratic formulas. Go ahead and get your notes and vocab out for this section. Okay, objective of this section is to solve quadratic equations by using the quadratic formula, or by graphing, or by factoring. Okay, and I'm going to put that in there because this is actually, I think, 5 and 6 type of concepts that we can use to solve quadratic formulas. And sometimes one concept is better than the other. So I'm going to show you that example, or show you that one strategy might be better for example 1 by solving this 3 different ways. And then after that, I'm not going to do that. We're going to find the best way to solve it, and then we're going to go from there. Okay, so first off, it does say that we're supposed to solve it using the quadratic formula. So here's our formula up here. Notice that that constant is with our ax squared plus bx. Notice it's set equal to 0. Here it's not. So step 1, in order to solve quadratic formula, we have to add that 20 over. So we are dealing with x squared minus 12x plus 20 equals 0. Once we have that, then we need to go ahead and figure out what A, B, and C is. A in this situation is 1. B is negative 12. And C is 20. So with that information, we're going to go ahead and plug this into the quadratic formula. Oops, you know what? I think I'm going to stick with their colors. Sorry, that way it's just more consistent. Okay, so we have negative 12. So the opposite of negative 12, I'm actually going to put in as a positive 12. Okay, so again, understand that that negative is actually saying the opposite. Then we have plus or minus. Look at this. We have a negative 12 squared. So when I plug that in, I have to put those parentheses around there. Then I'm going to say minus 4 times 1 and then times 20. And I know all of that is going to be over, all of that is in there, 2 times A, which is 1. Okay, now let's go ahead and simplify that down. We have 12 plus or minus the square root of negative 12 squared is a positive 144. That number is always going to be positive. And then we're actually subtracting 80 of that. And we're dividing it by 2. Okay? So keep simplifying. We have 12 plus or minus the square root is 64 over 2. And this is where I'm going to split it up into 2 different equations. I'm going to have 12 plus 8 over 2. And I'm going to have 12 minus 8 over 2. So I end up with 20 over 2, which means that I know x equals 10. And then I have 4 over 2, which means x equals 2. Okay? Right off the bat, those that are pretty comfortable with factoring could realize, oh, well, what times what gives me a positive 20? Added together a negative 12, a negative 10, and a negative 2. So we could have factored this with x minus 10 and x minus 2 and realized we could put a 10 in there and we could put a 2 in there for them to cancel out. So did that take about 1/5 of the time? Yes, but that is just because we knew our factors. We could see that and quickly factor it. If you would rather just go the no-brainer, let's plug in and solve to get used to that quadratic formula, go ahead and do that. We got the same answer, so we should be good to go. Okay, go ahead and do guided practice 1. Okay, and there it is. You should have got 3 over 2 and negative 6. Coming back here, this could actually be factored, but it would be the factor by grouping because that coefficient out there is 2. This is another thing that's nice about the quadratic formula, is that we didn't have to divide off that 2. You know, there wasn't anything bad about that 2. It just happened to be that A was 2. So we were doubling up in here and so on. Okay, so quadratic formula, that fail-safe way. We could have plugged that into our calculator as well, but I think we're going to wait and maybe look at one of these to do that. So I think we're going to solve A with the quadratic formula, and then we'll solve B with our graphing calculator. Okay, so here we go. We're going to go through all of our A equals 3, B equals 5, and then C equals negative 12. And I jumped right into this because I realized that it was already set equal to 0. So I already knew my 3 values. I was ready to go. Okay, again, let's read this out, that this is the opposite of B. So this is going to be a negative 5 plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Okay, and I'm going to have to move that up a little bit, I'm guessing, because I'm going to run out of room. Okay, then we're going to go ahead and just simplify. We ended up with negative 5 plus or minus the square root of 25, and then we have negative 12 times a positive 12, so plus 144, and that's all over 6. Okay, Keep going with that. 25 plus 44, 144 is 169. So we have negative 5 plus or minus the square root of 169 all over 6. And this is where I'm going to split it up. So I'm going to look at it two different ways. I'm going to say negative 5 plus square root of 169 is 13. And so go ahead and this ends up as 8 over 6. They say round to the nearest tenth if necessary, so they do want us to write this as a decimal. So we're going to say 1.3. Okay, we can also, I'm going to move that up here so I have room. Well, we have to also, goodness gracious, negative 5 minus 13 over 6, which gives us a negative 18 over 6, which gives us a negative 3. So sometimes our answers don't come out as pretty as other times. Okay, so quadratic formula still worked. So let's go ahead and look at this next one. Again, we're going to graph this one, but it looks like I'm going to have to subtract that 25 over because it does have to be set equal. 10 squared minus 5x minus 25 equals 0. Okay, I see right away that it looks like I have a 5 in common. So I'm going to go ahead and divide off of 5. So I'm dealing with smaller numbers. So that means that I'm dealing with 2x squared minus x minus 5 equals 0. And that's what I'm going to graph. Okay, so handy dandy calculator out. I'm going to go ahead and go through my y equals. If you were in a graph like that and you wanted to get out, there's a quit button right here. So if you hit second quit, that'll go away. So let's go back into y equals. I want to clear that out. I'm going to put in 2x squared minus x minus 5. And I'm going to graph that. And there's my answers. It looks like this one's right at 2. That one's a little bit iffy. So I'm going to go ahead and second trace and ask them to find the zeros. Does it matter which one you start with? No. I always like to start with this left one. So I'm going to go to the left of it. Then I'm going to go to the right of that. And it's going to tell me about negative 1.4. Okay. So x equals negative 1.4. And now I'm going to look at that one. It does look right at 2, but just to be safe, I'm going to ask it to find the 0. Again, remember left is now to the bottom of it because I'm to the left of my solution. And now to the right. Okay. Guess, no thank you. Ooh, I'm glad that I didn't because look at that. It's about 1.9. So x equals 1.9. Okay. Going through our quadratic formula, we would have got the same thing, but that is just a little bit quicker. So either way, we're going to get the same answer. Okay, go ahead and try guided practice 2. Okay, and there they are. Using the quadratic formula on this first one, remember the opposite of a negative 24 is a positive 24. Remember squaring it in here, make sure we put that in parentheses so that negative goes away. I went ahead and graphed 2b and then just asked it to find the zeros, and I found negative 1.4, and I found about 2.1 for my zeros. Okay, so many different methods, and that's what example 3 is going to go over, solving these using different methods. So let's go ahead and look at example 3. Again, solving. We're trying to figure out what value of x will make this equation true. We have learned that anytime that we want to look at this, we're going to go ahead and set this equal to 0 before we even decide what method we're going to deal with. Okay, so I have x squared minus 4x minus 12 equals 0. I have no number out front here, so I'm going to see if just maybe factoring will work. So I'm going to think of what times what will give me negative 12 and added together a negative 4. So let's see if there are any factors and sums that deal with this. Okay, factor and sum, our factor should be negative 12. Our sum should be negative 4. Well, getting really used to this, I'm kind of guessing maybe negative 6 and 2 will work. Negative 6 plus 2 is negative 4. Look at that. So remembering what this even means. I gotta make that smiley face a little bit less scary looking. There we go. That means that we have two binomials. Both of the first terms are x because x times x is x squared. We have a minus 6 and we have a positive 2. And we can set that equal to 0. Okay, please don't say our answers are negative 6 and positive 2. It's always going to be the opposite of that because x minus 6 is 0, which means x is 6. X plus 2 equals 0. So I know that x equals negative 2. Okay, we would have found those answers using the quadratic formula. We would have found those answers graphing. Actually, even completing the square, we would have as well. But look at that. That was so much easier. Okay, so keep that in mind. Remember that there is not one perfect way to solve these. Some students really like a certain way, so go ahead and try that as much as possible. But solve 3A and 3B using whatever method works the best for you. Okay, I realized even with that coefficient out front that I could quickly factor this. Knowing that my factor was 16, my sum was negative 17, so I used negative 6 and negative 1. I did have to factor by grouping on that, but really it didn't take too long. Finding out that x was 1/2 and x was 8. Looking at 3b, I could see that that wasn't going to work quite so well, so I went ahead and just graphed them and found the zeros. Okay, sometimes again that might be the best answer, best solution. Okay, great little table right here with determining what kind of method you should use when factoring. Again, use when the constant term is 0 or if the factors are easily determined. Remember, constant term is 0 because a lot of times we can just distribute out. Okay, graphing, maybe that's what you're going to use all of the time, but if you can tell that it doesn't factor very well. Using square roots when an equation can be written in this form right away, when it's just x squared equals some term. Okay, completing the square can be used for any equation, but is simplest to apply when b is even, okay, and when a is 1. So that could work on some of those that we had just done. And then quadratic formula for anything. Many, many different ways. One other thing we need to talk about is what's called the discriminant. In the quadratic formula, the expression under the radical sign, the b squared minus 4ac, is called the discriminant. It can be used to determine the number of real solutions of a quadratic equation. Most of the time, we are going to have two intercepts because when we graph it, 95% of the time, our graph is going to cross the x-axis twice. If our discriminant is positive, that's going to happen. And we notice that because remember, inside our square root sign, we would have like square root of 16. So if we had 2 plus or minus the square root of 16 over 2, that's positive. So because of that, we know that we have to put together two solutions and we're going, or two equations, and we're going to get two solutions. One that deals with the positive square root, one that deals with subtracting that square root. Okay, sometimes it actually equals 0. If our discriminant equals 0, so again, if I had 2 plus or minus the square root of 0 over 2, well, what's the square root of 0? 0. So that whole piece right there is going to go away because plus or minus a 0 is just a 0. So we're going to end up with 2 over 2. We are going to have one intercept. Looking at that as a graph, our graph is going to touch the x-axis one time and go on its separate way. So it would touch right there. Okay, looking at this one, if that discriminant is negative, we have no solution. Do you remember back when we were trying to graph and we were looking for a prime? Remember the prime just floated up here out of nowhere? It didn't touch that x-axis because, again, it had no solution. So think about that. If we did this one where we had 2 plus or minus the square root of negative 16 over 2, if that discriminant underneath the square root was negative, we would get no solution because there a number times itself cannot be a negative. So there's a difference. Here's a negative. This is what the graph looks like. We realize no solution. If a 0 shows up underneath the square root because our discriminant is 0, we get one solution. 95% of the time, we're going to get that two solutions. So this doesn't tell us the answer. It just tells us what type of answer we are going to get. Okay, keep that in mind. So we're supposed to state the value of the discriminant and then determine the number of real solutions of the equation. So it just gives us a really quick insight into what kind of problem we are looking at. So step one, we're going to have to go ahead and rewrite this because we do have to have it set equal to 0 before we can even look at that. Okay, so remember that our discriminant is b squared minus 4ac. So we are looking at b squared and we are subtracting that from 4 times a times c. So our a is 4, our b is 5, and our c is a positive 3 because we added it over. So let's go ahead and again just plug it into this equation. We have 5 squared minus 4 times 4 times 3. Okay, what kind of answer is that going to give us? Well, let's find out. 25 minus 12 times 4, whoops. So 25 minus 16 times 3 is 48. So what is our discriminant? 25 minus 48 is negative 23. Okay, so again, this is not the answer to this equation. We can't say x equals negative 3. Our discriminant equals negative 23. What does that mean? How many number of real solutions to the equation? Let's go back to our table. This is a negative number. Therefore, we have 0 real solutions. So 0 solutions. We do have to spell right for one. And we do have to put real in there. There are imaginary numbers, which we are not going to get into, but someday maybe you will. So we are going to say 0 real solutions. There are imaginary solutions here, but we're not going to look at those. Okay, discriminant tells us how many solutions we're going to have. B squared minus 4ac. Go for it on guided practice 4. Okay, and there they are. Finding a discriminant of 1, that is a positive number, so that gives us 2 real solutions. Finding a discriminant of 0 gives us 1 real solution. I would highly recommend having this chart out and understanding it when you're dealing with discriminant. Okay, this whole chapter in a nutshell. There are how many different methods that we can solve quadratic formulas. Some methods work better than others. If you get frustrated and you can't find the answer, grab that calculator and graph it, or grab that quadratic formula and plug in the numbers, because those are the 2 fail-safe ways that you can solve any equation. Okay, so this assignment is going to have a lot of the different types of equations that you can use. So don't just use that quadratic formula. Make sure that you can see whether it's a quick factoring problem or not. All right, go ahead and try the assignment for this section.